Now we want to develop the idea of a vector space. Okay, so we take the set of all vectors in R2. R2 is like your XY plane, if you wish. But it really is just a set of all column vectors that consist of a real number here and a real number here. Okay? So clearly 1 is a real number, 7 is a real number. This is a vector in R2. Negative 49 is a real number. Square root of 3 is a real number. We don't know how to express it in decimal, but it is a real number. So we have two real numbers here. Okay, so you can think of as many examples as you like of column vectors consisting of real numbers, of two real numbers. Those would be all such column vectors, all possible column vectors consisting of two real numbers are in R2, and R2 is a set of all such column vectors. Okay, can we add two column vectors and get another one? Well, yeah, if we add this and this, we get 1 plus negative 49 and 7 plus square root of 3. So our resulting vector would have those two numbers. Are those guaranteed to be real numbers? Well, yes, because whatever your two column vectors are, they consist of real numbers. So we're going to add the top two to get one of the numbers in our sum. We're going to add the bottom two to get the other number in our sum. In every case, we're adding two real numbers, so we get a real number. Why do we get a real number? Because we know that that's one of the properties of the real number system. If we add two real numbers, we get a real number. Therefore, if we add two columns consisting of real numbers, we get a column consisting of real numbers. So, add two, get another. We're going to say, yeah, it satisfies this condition. Okay? Now, is addition commutative? That means addition of these things. Meaning, if I add this one to this one, am I sure that I would get the same thing if I reversed the addition and did this one plus this one? Okay? And I kind of said that wrong, but you get the idea. If I reverse the order of addition, well, again, I'm just adding the numbers in the first row to get my number in the first row for my sum, adding the numbers in the second row to get the number in the second row of my sum, and addition of real numbers is commutative. So that addition of vectors in R2 is commutative, because addition of real numbers is commutative. What about associative? Well, if I've got three of these things, it doesn't matter which two I add first. If I add these two first and then that one, or if I do this one plus whatever I get when I add the last two. So that, again, is just a property inherited from the real numbers. For each row, I'm just adding real numbers. Doesn't matter how I group them. So, again, this space, this system of vectors, inherits the associative property of addition from the real numbers. Now, the challenge is not in understanding that. I think it's pretty obvious to anybody that thinks about it a little bit. The real problem is, how do you write down your justification for believing this? You can't just say, well, it's true because I believe it. You know, it's pretty much what people do with politics, but it doesn't work in mathematics. And it's true on both sides of the spectrum and in the middle of the politics. I'm not making a comment on any political stance. But I will say the kind of thinking people do about a lot of things in life, not just politics, isn't going to stand up in mathematics. Okay? We have to know how to write this stuff down. Okay? I think Kant, who I think is wonderful, does a wonderful job of presenting things, said when he was taking his courses at MIT, he said, why should I write this down? It's obvious. Well, you got to write it down to make sure it's obvious. You got to write it down so you can connect things, so you get used to writing things down in a way that connects things. And there's a lot of stuff in mathematics that's a lot tougher to understand than this, and you really do have to be careful to write it down and make sure what you think is true really is true. And eventually you get to the point where you say, well, I suspect this is true, let's check it out and let's test it. Okay, well, we've looked at these three properties for vectors in R2, and we see that all three properties are satisfied. And they're satisfied because of the rules or the properties of real numbers on addition.